Hi everyone, in today's video we're going to have a look at major developments in technology. So to just show you what you'll need in your exam, so you're going to need to give some examples of real life products and how they developed over time due to changes in technology. Now it would not be physically possible for me to go through every single example of how every single product has evolved. Um, but pretty much every single product that you see today is another iteration of a product that exists 10, 15, 20 years ago, that have just, as technological developments, don't know why it's so hard to say, because of technological developments, the product has evolved, it's got better, like in terms of how it's been manufactured, it's got better about in terms of how it works, so loads of different things. One thing that you can guarantee in your exam is that it will give you a product that you are familiar with. You might not be familiar with that particular brand or that particular model of what it is, but it won't give you a completely obscure product you've never seen before. Most commonly, they like to do things like MP3 players, TVs, games consoles, mobile phones, those types of things. So yeah, it might not be that it's the exact mobile phone you know, but you can understand that it's a smartphone compared to like the really old school cinder box style phones as well. So there is one particular area they do make sure they talk about in the exam, and inspect quite a lot, is microelectronics. The reason being that the whole microelectronics like boom and the development of it all is essentially what has paved the way for every single electronic device that you see today, whether it's from your gaming laptops to your mobile phones to whatever it is. It's such a crucial part to it. So I'm going to sort of go through the highlights of what changes have happened and why and like how that's happened. So this is the bit you definitely need to know, and then later on, I've given you a couple of examples of different products that have sort of been affected by it as well. So at the start of the 19th century, you got basic electrical circuits and batteries, which not very powerful, don't last very long, very big, very heavy. Then at the start of the 20th century, you have what is called a thermionic valve, also known as a vacuum tube, which is if you see this image on the right, that's this. Okay, so this device basically let you control the flow of an electrical current. It was basically the start of being able to have like radio signals essentially. So you got radios, TVs, computers. So it was the start of being able to send and receive signals basically. Problem was it was absolutely massive and it consumed a huge amount of electricity and also was unreliable. I don't know, you're all definitely too young to remember, but it's like if you ever had really old school style speakers and dodgy internet and you had your mobile phone next to it, if someone was going to send you a text or call, about 5 minutes before it would start making dodgy sounds. Obviously, 20th century is way, way before that, but in terms of like how inconsistent signals can be and that type of thing. Then you've got the 1940s, so this is where you start to have the startings of microelectronics. Okay, so what you've then got the invention of something called the semiconductor. So this was created by William Shockley. Shockley is a very apt name for someone working with electronics. There you go. Basically, discovered that semiconducting properties of materials like silicon can be used to make switches and amplifiers on circuits. So that's why today we still use silicon chips. And because you realize that you can make chips a lot smaller, that's when you start having the idea of miniature electronics, the whole micro small electronics. So that's why circuits have started getting slowly smaller and smaller. So that started in 1940. Next, you got the 1950s, which is where they start getting your integrated circuits. So this is where you start to have multiple transistors and other little smaller components inside those chips. So you have your chips, and now they've started to realize that you get more and more components within those chips, so you don't need to have as big a circuit board or as big a component to have it all fitted in. This really was like the dawn of microelectronics now, because you realize, okay, we've got our silicon chips in the 1940s. We now know within that we can fit hundreds, if not thousands, of transistors and other components. So we can get rid of these huge, like, internal guts of electronics that we don't need anymore. And from then, it kind of steamrolls, and people keep getting more and more development of small electronics, and it keeps getting faster and faster. So at this moment, we're currently at the stage where about 10 billion transistors can be put into one device. So this is what basically referred to as like large scale integration. I've missed the complete. Sorry, that should be large scale, not later scale. Yeah, my bad. Basically, the more components you can put into it, the better quality and more in-depth electronics can do. This does have a huge amount of benefits, obviously in terms of the development of technology, but there are some drawbacks to it as well. The main benefits being you can get a lot more powerful computers and medical equipment. If you ever watch like a show from the 90s and you see those old laptops they've got, and they talk about how much power and RAM and things like they got, and it's like compared to today, it's ridiculous. The same with like USB sticks or like floppy disks compared to now. Just the amount of quality and how much power things can get compared to then is just completely incomparable. The drawbacks of that can be things like the dawn of like social media. And with that, you have like things like cyberbullying. Because of social media now, it's up for debate here, and this just kind of bleed into a bit of a social moral ethical issues theory as well. Is before social media, cyberbullying wasn't a thing. And from cyberbullying, there's also been a higher rate of teenage suicide, particularly around the whole idea of like Instagram versus reality. People posting their best lives on Instagram, going, "Oh yeah, I'm just living on the beach doing this," and in reality, that's not what they're doing. But then people are comparing themselves to that, and they feel inadequate about their lives. So it starts to cause depression, and there has been quite a sharp rise in suicides, particularly around more so younger females than males. Um, but yeah, cyberbullying, social media bullying, none of that was a thing before mobile technology was a thing. So, since the development of integrated circuits in the 1950s, not just like mobile phone technology, but there's been loads and loads of developments just across the board in terms of like design and engineering industries. So, just to show you a couple of examples, things like using books and journals for research. Obviously, at the start of the year, I got you to have an induction in the library to have a look and be able to do journals and books and that sort of thing. But for the most part, it's replaced by things like internet searches. And I don't know about you, most of the time, if you don't know something, your first reaction is, "Oh, I'll just Google it dead quickly." And the fact that you can do that on a mobile phone in your pocket rather than having to get to a computer is massive. So you've got information right at the tip of your fingers constantly. Communication by letters or landline phones, obviously completely replaced by mobile phones, Zoom, texting, social media. Um, I'd be interested to know if anyone has any landline phones at home still anymore, where it's actually wired and connected to the wall. That died out. When did that die out, really? I mean, I had one when I was growing up in the 90s, early 2000s, so probably, what are we, 20? I don't know when that kind of. Well, I'd be interested to know if anyone has got those or not. Then, like sketching, drafting, you may have seen videos, particularly if you're going to be interested in doing like architecture or engineering. You see people doing technical drawings on big drafting tables, replaced a lot by like graphic tablets using CAD, Fusion 360, SolidWorks. The fact that you can do your technical drawings in like a couple of hours as opposed to like a couple of months. Face-to-face meetings. Okay, this is more prominent now because of things like COVID, but the fact you don't need to meet face to face a lot of the time now, you can do it over Zoom, you can do it over Teams. Um, what was the other one? Skype, which seemed to die away, which was weird. Handmade models and prototypes. So obviously, in terms of like prototyping products to talk to clients, you can make it out of foam, make them out of clay, that sort of thing. We're actually now, again, with CAD, do virtual modeling. You can do rapid prototyping, so 3D printing parts really, really easily. Running destruction tests and calculations. You can actually run physical simulations within CAD packages, finite element analysis, so you can test strains and things like that compared to build a bridge. Okay, where are the stresses and strains? Is it going to hold or not? Then you got aerodynamic simulation, so that would be computational fluid dynamics, so you can see how aerodynamic something is. So if we take like F1, obviously in like the cars, they're testing certain parts like a new front wing or rear brake ducts or whatever it is, and trying to test how aerodynamic those are. Um, One of the other things that I've said down at the bottom is you can say could possibly be a negative is you did used to have what like highly skilled individual workers that can work certain bits of machinery that have been replaced by like CNC machinery, 3D printing, automation, CNC routing, milling, those sorts of things. So you've kind of almost like a lost skill where you are starting to get away from like a person that knows how to do this by hand because machines can do it. So that is a negative in some sense of the world, but I do think there's now more people at the time are a bit like, oh no, I don't like doing that. You do see that with a few more like older school style D teachers and stuff like that, as well as they operate. Oh, it's not like it was in the day. You need to do your hand skills. whereas really need to embrace the new technology. If you think about the fact like laser cutters, 3D printers, the fact you can buy a 3D printer for like 180 quid that actually works pretty decently and can make stuff that actually to make by hand would be really, really difficult. So there's just a few different examples of how developments in technology have improved day-to-day business and day-to-day workings of things, basically. And all that started from the 1940s of the silicon chip, then the 1950s where you have integrated circuits within that silicon chip, and then all these things have developed since then. So I'm going to show you basically apply it to a couple of examples. So we'll start with the radio, okay? And it could be any example here. So the radio could be a one that comes up in like an exam, but I want to show you how changes to design technology, of major developments in technology rather, have developed the radio from when it first came through to today. So we'll start with the 1930s. So it starts to become available. They're handcrafted, which reflects the style at the time. Technology, as we talked about before, is the thermodynamic valve, which is that massive valve. Basically, it's a very weak sort of current and signal, so you can have a couple of radio stations. Signal won't be that good. You may have seen this particularly if you did like history and people like in the World War, they wouldn't have TV, so they'd have a big radio and all crowd around and listen to the stories being told on the radio. Beautifully made, but handmade, so obviously they're like you're not mass producing them. Beautifully made. Then you've got the 1940s. So this then is the introduction of something called backlight, which is a thermosetting plastic. So whereas in the 1930s they were handcrafted out of hardwoods, the 1940s you're starting to try new materials that can start to be mass produced or produced in a bigger scale than handcrafting things are. So when we talk about major developments in technology, yes, I've just talked about microelectronics and the parts that make the things work as well. It could also be about how the thing is manufactured, because the manufacturing processes have developed a lot as well. So we just talked about laser cutting and 3D printing. You've also got things like injection molding, blow molding. All these sorts of things have developed over time, and once it becomes easy to make things, you can make more of them. So 1940s as new material comes in, so backlight, as I said, thermoset plastic. Then you get the 1950s, so backlight becomes a lot more commercialized, a lot more readily available. And then here you have the major development of the transistor that comes into play. So this basically lets you have a better signal. So if you actually see their comparison in the size of a transistor compared to the thermodynamic valve, and then you start to get the idea of having like portable electronics. You actually don't have to have it plugged into a wall at all times. You can actually walk around with it a little bit. Still pretty heavy. It's portable, not in the sense of portable nowadays where everything is on your smartphone and that's it. So you have a little bit more movability with it. Then you got 1960s. So the changes here really is more to do with like fashion and material. So like fake, like leatherette, like polymer comes into play. So you start to get like new different looks to that. There's also just the same technology just keeps improving with integrated circuits. So you have a better, clearer sound. So that you start to have music coming in a bit more. Obviously in the 60s, that's where you start to have things like the Rolling Stones and the Beatles. So there's more of a push to have that sort of customization. Then in the 1970s, there's a lot more of a use of thermoplastics, because then you started having injection molding start to become a lot more prominent, because you could start to make things a lot more often, a lot faster, a lot easier. It was also, obviously, we had the space race, which culminated in 1969, where we made it, I say we, America made it to the moon. And that sort of kicked off the whole space age design movement, where everyone was convinced in 10 years we'd all be living on Mars. So everything all had like a sort of bubbly sort of look, because they were convinced this is how everything would look in the future. Then you got the 80s and the 90s. So electronics started to develop a lot more. So you've got cassette tapes, and this is where I'm going to start to feel very old. This is what I had originally in my Blazer pocket before you had your phone or CD player, you had a cassette tape player. And then other recent developments from that, you get things like having ergonomics. So if anyone's really into like their gaming, if you look at things like older controllers as well, or older electronics generally, they weren't designed to be held comfortably because ergonomics wasn't really like a considered factor. And then suddenly they realised that does play a factor, and then that's why the shapes of things start to change as well. You can make things lighter because you're making them more out of plastic. The circuits aren't as big, so it's not as much weight on the inside of it. Introduction of screens onto products as well, so you can like skip songs a lot easier. And then to now you've got like digital radio where you can literally have like thousands of radio stations. You can listen to stations from France or Germany, so you can listen internationally. You've got a much better signal. You can have a signal literally like anywhere in the world. So that's a little breakthrough basically of taking the radio from stage one to where we are. So you can see along the way, yes, you had the microelectronics, which was the big push. But then you also had development of new materials and new manufacturing processes. So all those things have resulted in how just one radio or one product in the radio has developed over time. So I will show you another product in a couple of slides as well. But that's sort of how you need to be able to explain how our product has changed over time. So in terms of not just products, we also got some new materials that have developed over time. So first one is glulam. So technically I'm cheating here. This isn't a new material, but it's making a comeback, which essentially just several pieces of timber glued together to create a strong composite, essentially like plywood, basically. So you just have different layers on top of each other. And the reason why it's stronger is that basically you remove all the knots and defects, so you've just got the really strong grain going onto it. The reason why it's so good as well, it's got a good strength to weight ratio compared to steel, because obviously steel is stronger, but it's a lot heavier, whereas glulam isn't. It's also really easy to mold into shape, so you can literally, like, well, not steam bend it because the glue would weigh, but you can actually press and clamp it into place to make nice, like, frames for structures, so boats and like beams and those sorts of things. Then you got Kevlar. Now, Kevlar actually is a brand name. I haven't put the actual technical name on there, so I apologize, but you can say Kevlar in your exam, that is fine. But that's just an artificial fiber that has really good toughness and tensile strength because of how dense it is and because of the actual structure of the chemical bonds that you've got in there. And then you can mix it with resin as well to make even stronger composites. Most commonly, most people know it as like bulletproof vests. And it's also used for things like gardening gloves, or like protection for like chefs cooking, so you physically can't cut yourself. You've also can start using it in things like puncture proof tires and those types of things as well. We've also got precious metal clays. So we've covered this in smart materials a little bit, but we'll go over it a little recap. It's just a craft material basically, and with it, inside it, you got lots of microscopic particles of like precious metal, so your gold, your silver, those types of things. And it's put inside what's called a pliable medium, and what that just means is that's like the thing that holds it. So in this instance, it's just clay. So basically what you do, like with clay, if you ever used it in art in secondary school, is you'll put it into the shape that you want, and then you'll raise the temperature of it. And what you're doing is you're raising the temperature until the particles of the metal fuse together. And then the clay, because the melting point of clay is lower than the metals, the clay just burns away, and then you're just left with the precious metal around it. So it's really easy to make the shapes that you want. And then essentially you burn the clay away, the metal melts together, and you're left with your thing. Typically, because you're removing the medium, the clay on it, it ends up shrinking by about 10%. So when you're designing and making it, you need to factor that in because it does shrink. Then you've got nanomaterials. So this again is a very, very modern thing as well. So this is where you got particles of an atom that can range from like 1 to 100 nanometers, which is essentially, and I have no idea how many decimal places that is, but that is how small it is in millimeters. Okay, so tiny, tiny, tiny. So it is being experimented with to make nanoelectronic devices, which they're saying could be the next development. Like obviously, silicon chips was like the massive development, and what they're hoping is that nanomaterials can be that next massive development. It's not quite there yet, but that's what they're hoping the next step will be. You've also got things like graphene, which is graphite, but it's like one atom thick of graphite. So that the hope is that you can like coat anodes on it to extend battery life so it lasts a lot longer. Basically, the problem is that it's quite difficult to get a one atom thick any material, but they're slowly trying to develop and figure out how to do that. So it is possible to like roll into tubular shapes to get very high tensile strength. You can get like graphene, like squash and tennis rackets and those sorts of things. They do have very good tensile strength, hardness. They're also very good at conducting electricity and heat resistance. So it does have good potential for things like medical uses. However, because it's relatively modern, there's still the idea that it might potentially like be toxic and those sorts of things. So there's sort of things that need to factor into place to check because it's so new. So new methods of manufacturing. So we talked about the development of things like injection molding and those sorts of things. Those aren't new now, but at the time of like the radio, it was new because it resulted in a new casing. But these are more modern manufacturing methods that essentially replace an old manufacturing method because it's just easier and faster to do it. So we have talked about this in metal processes. Excuse me. So we've got electrohydraulic forming. So this is now a single stage process to form like complex sheet metal parts. Okay. So originally the way to do this was to use electrolyte controlled explosions to actually shape the metal. So if you look at the diagram here, essentially you're going to have your bath or your dish or whatever it is, your container filled with water, and you have clamped your material. So this is our blank, our sheet metal here, and this is the mold that we want to form it around. So what will happen is you're going to have your power supply, and you're just going to do an electrical spark, and that electrical spark will cause the sheet metal to bend around the mold, and the vacuum sort of pulls down to help that process go along a lot more as well. So that electrical spark causes a shock wave that basically generates like force that will make the metal go around that shape. So it's like an instant process, a lot faster. Then you've got 3D printing, obviously not new, and we've talked about 3D printing in the CAD CAM theory as well. So you can now start to do 3D printing in metal, starting to become a lot more popular. Very, very expensive. I have requested 3D metal printers, but they are very, very expensive. So it works in much the same way as regular 3D printers do, in that it does layer by layer. But what it does is it uses a laser to sinter, and by sinter we mean fuse, the metal particles together. So with normal 3D printers, obviously they heat the polymer up and it cools as it's going up. So you don't necessarily need to fuse it because plastic's melting point is so low compared to metals. But as the laser is like fusing it together, it allows you to make a nice strong metal 3D shape. It also lets you do things that are massively complex that you wouldn't really be able to make in any other way. Next, you've got fiber injection molding. So injection molding we know all about. So it's a pretty similar process, to be honest with you. There's two ways of doing it with fiber injection molding. One is that you can add um, plastic fiber, like carbon fiber fibers, into the hopper as it's going through. But you have to have an increased heat because it requires quite a higher temperature. The other way is that you can have carbon fiber roll that feeds into the actual chamber as it's going through the actual chamber and heating up and going into your mold. So as the process has already started, you're then feeding in carbon fiber to it as it's going along. The benefit of using carbon fiber this way, again, is one, complex parts, but two, it encourages recycling because carbon fiber typically can't be recycled. But because if you're doing pellets and you can get the temperature high enough, it's fine, you can put it there, and it kind of encourages the idea that you can recycle it. So laser beam welding, so new form of welding. So this basically will let you create a very intense heat, and it will let you join multiple metals together, and it's a very, very fast process. Benefit being as well is that this particular welding will let you weld dissimilar metals together, because typically with normal weld like MIG and TIG is you have to do steel to steel, aluminium to aluminium. You can't do dissimilar. It's also very, very accurate, and the heat that you use stays very focused on that one particular area, so it's not going to distort or warp or twist the metal around it. Because it's so accurate, you don't require any finishing to it, and it will let you do very, very thin components because it's so accurate. As I say, you're not going to distort an area of it. So like it's such a focused point. Whereas if you've done welding in the workshop already and you've got the nozzle on your end, the heat does go to like a diameter around the nozzle as well. So this, not the case. The disadvantage being it does have a huge initial cost, and it does require quite a lot of cleanup because you have to make sure everything is nice and clean. There's no dirt on any lenses or anything like that. Then you've got physical vapor deposition. This will let you make very thin layer of plastic around a product. So it's very good for doing things like food packaging, decorating products, or cutting tips and things like that. So all will happen is that you'll have your material, you'll have the products that you're trying to cover clamped in place. You'll have your material and you're going to heat it all up. Then as the plastic evaporates, it goes upwards because heat rises, and it's going to go around the material and form around it. And you have the vacuum that will suck all the other air out of it, and it will just leave a very, very thin layer of the material over the product that you are trying to cover. Next, you've got the Internet of Things, which is a very lazy, weird name. Well, it's basically the connection of devices to Wi-Fi or network or wherever it may be. So serious applications might, as we talked about in the CAD CAM thing, is making sure when you've got like automatic stock check of levels. So we talked about electronic point of sale. So when you scan a barcode, um, it's basically checking, okay, we're running low on this particular product, better order some more, and it'll do it automatically. So there's no need for that human involvement because you're removing the risk of human error, but also making sure it's just on top of it. Slightly more boring scale might be the case of like you have a smart fridge and it can let you know, oh, you're running out of cheese or you're running out of butter. Um, the whole idea being that you want to make things as automated as possible so that you it requires as little maintenance as physically possible as well. So there was reports they started to make Teslas, so Teslas can do like a diagnostic test on themselves. So if they know your tires are like getting worn out, or there's a certain part in your car that needs fixing, or needs a new part to it, automatically you can order it yourself, which in theory is fantastic. In practice, there may be other issues around that as well. So then you've got the advancement of CAD and CAM. So we've talked about this quite a lot as well. So the use of ideas like CAD modeling lets you create a 3D digital model of whatever it is you're doing. So then you can do things like we talked about finite element analysis and computational fluid dynamics to actually physically test a product or digitally test a product rather than physically test a product without wasting materials and that sort of thing. It allows to let you create things like STL files, which you can use for 3D printing and milling, DXF files that will let you laser cut and CNC routing, along with having like cloud-based systems like the OneDrive that we use in college. So you actually don't need to have a USB stick anymore. It's all just in the air. Same with like on Fusion and your work. The idea is you can do your work in college, close it, or save it, obviously close it, go home, and it's still on there. You don't need to have transferred it over yourself. There's also, which you might see, which is very, very cool, like virtual reality has been used in things like shopping. So you can actually like virtually like try on a pair of shoes or try on a dress or something like that. So it'll like scan you in, and then you can sort of select different clothing to try on. You can start to do that, and so I think it might be Nike. I'm not 100% sure on that, but they'll let you basically like, do that with customizing trainers, so you can actually digitally like try different things, and you can scan yourself in, and you can see how it looks as well. So there's a lot of very, very cool developments within that. So a couple of other examples to show you. I'm not going to talk through this idea, but you can sort of see just from this image like how phones have changed. So first of all, you got the idea that technology has slowly gotten smaller, microelectronics you get smaller. Then as the technology gets better as well, quality of screens, and they start to get bigger again. Then also the idea of like um, video game, like computer game consoles, how they've developed. So the idea of like ergonomics, you can see controllers starting to get better, see the technology getting better, the graphics getting better, and that type of thing. I won't go into those examples, but just to show you um, other examples that may be used. Now, I'm not going to talk through this massively. This is taken from a website. I just want to show you this so I can give them credit because it is a brilliant website for this sort of thing. So this is just tigermobiles.com/evolution, and this has got a really, really brilliant interactive, basically, development of how a mobile phone has developed over time. So essentially, this next couple of slides is what I've taken from here. So if you want to have a look at it, please do. It is brilliant. So this is just showing you basically how mobile phones have changed. So from 1983 to 1990, so the first portable mobile phone, like massive old thing, cost about $4,000. Um, Quite a status symbol to have it, but comparing it to now, it's shocking. Then you go to 1991, 1994, so you start to get your first like smaller one. There's a screen involved in it. Mass production starts to come into effect, so you start to be able to produce it a little bit better, more cost effective. Um, then introduction like Nokia starts to come and use like transition of using like mass production and screens. Then 1995 to 1998, start getting like coloured screens, that sort of thing. So Siemens starts bringing like phone displays of colour on them. Then you start getting different keyboard panels, different cases for your phones. Then 1990 to 2002. So as you can see, how the shapes are starting to change, better coloured screens, introduction of wireless networking. Again, same thing again. So introduction now of 3G, so you get much faster download speeds. Um, then you start to get the first iPhone, so 2007, 2010, so the sort of like first smartphone you've got. It's the idea of like touchscreen. You can swipe rather than having buttons, so you've actually got rid of the keypad. And then basically from there we have how the Apple has changed over time. So if you compare, like, I'm going to assume most of you have got an iPhone. I hate Apple, as we all know, but most people have got an iPhone. You could try comparing that one now, 2007, to the one you've got in your pocket currently. So 2011, 2014, basically starts having like 4G, a lot more available. You've got Siri starts to come into effect, so voice activation comes into play. Then you have got 2015, 2018, screen size is getting better because the quality of the image is getting better. So the screen is actually 57% larger than the original phone. You then have things like Apple Pay and Android Pay start being a thing, which is quite a large thing now. So you actually don't have to have your card with you, you have it digitally, so you can just swipe dead easily. And then currently you've got like 5G is now a thing, ultra high resolution, data pretty much everywhere, so video streaming, mobile gaming, all those sorts of things. So those are just another example, not quite as detailed obviously as the radio one I'm going into, but if you're interested, have a look at that website I've shown you. So it's up there. Really, really good breakdown of how the mobile phone has changed over time. And obviously, a lot of it is down to having your silicon chips, your integrated circuit. So from having that microelectronics development has resulted in a huge amount of changes to a mobile phone.
So the first one, so we've referenced the two different technological developments. Describe in detail how each has impacted on the evolution of modern electronic products. So 40 marks. So 40 marks for about two things. So basically that's 7 marks for each development, which is 3 or 4 points each with an explanation. Call it 4 just to be safe. Think carefully about what you pick. Obviously it's got to be something you can write about, something you can write 3 or 4 points about. So it could be development in the actual electronic components themselves, like the transistors and silicon chips, that sort of thing. Or it could be a manufacturing method that would, like, say, make the casing for it. So the casing for a cassette player or a CD player or an iPod, that sort of thing. So pause the video, give yourself 40 minutes, then unpause it and we'll go for the answer. So got 2 examples. So as we talked about a second ago, it could be a manufacturing process, it could be an actual electronic component development as well. So with, you could say, injection molding, so that comes into place and that lets you then get loads of different colours of products. You can make things on a large scale a lot easier because once you've got the mold, you just keep making things over and over again. You can make really complex parts, which then means that it becomes cheaper because you're not making as many parts fit together, so you can make more complex pieces as well. And then it's a good electrical insulator because it's a polymer anyway. So it just involves making the casing a lot better. And then, as we talked about with the radio, development of the transistor, so you have the miniaturization of electronics. So it then becomes a lot easier to move around, it becomes a lot more reliable, it doesn't get out as much heat, it becomes a lot cheaper to produce. And last question, so the application of new technology and the use of modern materials have changed the function and use of many of today's products. So for each of the following, infrared or Bluetooth, smart materials, microchips and rechargeable batteries, name a specific product that makes use of the new material or the new technology. And then part B, explain how the new technology or modern materials improve the function and use of each of the products you have named. So next question, so the application of new technology and the use of modern materials have changed the function and use of many of today's products. For each of the following, infrared or Bluetooth, smart materials, microchips or rechargeable batteries and technology, name a specific product that makes use of the new technology / modern material. And then part B, explain how the new technology or modern material has improved the function and use of each of the products you have named in part A. So just breaking that down first of all, part A, quite simple, 4 marks, 1 mark each for saying which one is correct. And then part B, so 24 marks to write about 4 different products. So obviously 24 marks, you think, oh my god, that's a huge amount of things, which it is, but 24 marks for 4 things, which just means 6 marks for each product, which again, break that down more, is 3 points with explanations that you need to have. And then obviously, because it's a long mark question as well, there needs to be a summary at the end of it, and then you will be assessed on your spelling, punctuation and grammar as well. So pause the video, give yourself 28 minutes, and then we'll go through. So we'll just look at one example just to show you what we'll go through. So if we do, say, take Bluetooth technology, okay, all right, so you could say things like mobile phone, and then take that and then, okay, how's that changed it then? So you could say, okay, that could be hands-free. So you got things, so like in the car, you don't need to have people on their phone while they're driving, which is then a big thing about safety features, that sort of thing. You can then share information. So instead of like sending text, you can Bluetooth, and you can send documents between two things. You can connect your phone to your laptop or anything like that a lot easier. So there's all these different possible things you can have. It's just making sure that the one you've picked, you've got enough that you can write about. So you take smart materials, so you've got to name a particular product that has been picked for. So smart material, and a big one we can always talk about is like children's food, and the fact that it is thermochromic material. So you could then say, okay, that would be a safety thing, because then you will know that it is a certain temperature where it's too hot to feed a certain child, or like, again, it could be a safety feature where it goes red hot, so you know, okay, don't touch it. So there's loads and loads of different possibilities you could look at. It is literally like with anything where it says you get to choose, just making sure you pick something that you think you can write about. If you've got any questions, send me a message on Teams or via email.